The first test to create a functional microprocessor in Blender was successful so far. There is a working divider that can handle 8 and 16 bits. There is also a multiplier for 8 and 16 bits. Everything is built from the basic building block called NAND. But the FPS is bad, very bad. So I'll try again, this time a little less complex. What can you see in this video series? Creating a simulation for a functional microprocessor. I will use the Intel 4004 instruction set as a basis. The Bizicom 141 PF calculator is to be brought to simulated life. What can you learn here? I'm going to talk about basic computer science. Basic logic circuits are presented. First we start Blender. I'm using the Flatpak version under Linux Mint here. Start Blender from the terminal. It is important that you use it for debugging. We switch to scripting and test the first output. If everything worked, the output should appear in the terminal. First, let's create a folder under Blender's add-ons directory. We then create several files. And then we open all the files in a text editor. First we write the script for the main file. The dictionary bl_info is located at the beginning of every add-on and defines it. This is the name. This is where the author comes in. The version of our add-on. Here the user can find the add-on. Another short description. You will find the add-on under this category. The actual script starts here. First we will import the Blender API, as well as all other parts of the add-on. This will be explained later. This method is executed when the add-on is loaded. Here all usable elements must be registered with the Blender API. We add a Start button to the menu bar of the 3D window. Due to the inner workings, we still need to add an object to the Blender API. This method is executed when the add-ons are deleted again. Here we reset everything to its original state. This is where we write our panel. We import the Blender API again. We create a class and derive it from the Blender panel. This name is here. This name is used internally by Blender. This is the area where you want the panel to appear. Here is the 3D window. This puts the panel in the sidebar. This name appears here. Here we add the buttons that should be displayed in the panel. The name is the name used by Blender. Now let's define the buttons. First, the wire. This is derived from the operator type. This is the internal name we used in the panel. This name is here. This method is called when the button is pressed. We only issue a message. And then let the action end as successful. Now we use the magic of copy and paste and create the other 3 buttons of the panel. This is where the Start button comes in. Everything as already known. However, we call the run method of our main class and print the result. This method adds the button. And now the main class. First we create a method that calls the idle method. What this is all about will be explained in a later video. The main class only contains two methods for now. The run method only returns run. The idle method doesn't do anything for the first time. And now let's start Blender and try out the buttons. We have shown all method here below. And all messages are also displayed in the terminal.